Craftsman. 120 volts. Not working. Capacitor. Electrolyte. Electrolyte from capacitor. This is high voltage problem because this capacitor is rated 200 volt and they have plugged this in 230 volt. That's why it is swelled. We're gonna put this capacitor that is 450 volt maximum, because 230 volt alternative is have the max voltage of the amplitude 300 volts, while 120 volt alternative power line has the maximum voltage of the amplitude 160 volts. So 200 volt for 120 volt alternative is okay, but for 230 volt alternative we need 400 volt and above. Now this charger uh, has no varistors. You see, here is the cable. This is the fuse, this one, going from here to here. Then some resistors to discharge this capacitor, filter capacitors, and this inductor here. In parallel we go to this bridge of 4 diodes, and from alternative converting to direct current DC, and then is this capacitor in parallel to filter the ripples. In case we have a varistor like this charger has, this is a varistor, and you see VS1, the varistor, and the varistor is always parallel to the input voltage but after the fuse. So in case there is a higher voltage, these varistors short conduct current and then blow the fuse, so the current is disconnected. You see here the cable going this direction and this one through the fuse, then going to this varistor that connects both lines. While it looks similar to this component that is the thermistor, we can see TH, that means thermistor. This thermistor is in series of the input voltage. You see, from here to the fuse, then going to this filter capacitor and inductor. Here we have this thermistor that just slows down the surge in rush current that the big capacitor here uh, needs to charge, and thus in this way doesn't damage the bridge or blow the fuse due to this surge in rush current. That's why uh, this varistor is this thermistor is used. But the circuit can work even if we put a wire here and bypass this uh, thermistor, and also the circuit can work even if we remove the varistor, that is just protects a protector from high voltages. If we have a varistor in a 120 charger, 20 volt charger, we have just to remove this. You can, if you want, you can replace it with something that tolerates 230 volts, but you can leave it without it if you want, and it will work. In this charger we have to change just this capacitor, and I think the rest of components is universal for both uh, types of power lines, like 220 and 120, because these manufacturers produce for the entire world, so they don't want to make uh, many types of chargers, so make just one and put just this capacitor, because capacitor is important uh, uh, because the size and the power matters in two different voltages. Now this is 68 microfarads and is in a low voltage 120. It is like this, but in 230 volt you can put a smaller capacitor, because uh, the high voltage uh, can charge even more power in smaller capacitors. But I have this one that is way too big, but anyway it will work, and I don't think it will cause any damage to the bridge here or the fuse. I hope so. Let's change and try in 230 volts. Remember, always remember the side, because these capacitors are polarized. Just do not think about the polarity here, but anyway you can find by looking at the diodes. So the negative part is here. Okay. Okay. Just in case, for not having any short, we use this lamp in series. I see no any sign here. Ah, okay. So in order to have any light on here, you have to put the battery. See? But try to put direct, and this is charging. Okay, this is done. Testing the components. You can test the fuse with continuity. If it is like this, it means the fuse is okay. Then you can test the diodes in diode mode, still in continuity, and in one side you will have a short beep like this, 0.6 volt, and from the other side you will have nothing. So this means these diodes are okay, four of them. If any of them is like this, shorted, then the diode is dead. Or if there is no sign like open, that is the rare condition with the semiconductors, it's again broken. You can visually check the capacitor or measure the capacitance, and it must be close to the rating here, 100 microfarad. You test the transistor, the MOSFET, with diode modes, and you should not have any short. Like, see, this is okay, this is okay, 3 pins. Not, this is not okay. This is the Schottky diode that is output from this transformer. You see the symbol here. There are two diodes and having one common cathode or output. You can test it. You can test it. You see? Both diodes are okay. Now you have another diode here. Okay. Now we have to measure the voltages in order to test this capacitor. Let's plug it in, and to test it fast you just go here with voltage. You measure the AC voltage, sorry, here AC voltage, and it is okay. We keep going before the bridge. here and here, and we have AC voltage. Now let's measure the output that should be in DC. 316 DC. That's why we need a capacitor that is with 400 volts. So till here everything is okay, and this is dangerous voltage, so you have to keep it uh, far in the far side from your body, having the gloves. And now let's see the output voltage here in this diode here. This here are the pins of this transformer, and you see these pins here go to both sides of the diode, and we have to measure these pins here with the output of the diode to measure the DC voltage. The DC voltage. And you see it is 12 volt. It is not enough to charge a battery that is 20 volt, but when you put the battery on, it will rise the voltage. We have to measure voltages in two conditions. One, when there is no battery put on, and another time where the battery is on, to know what is happening in the circuit. So the next time you can uh, face the same charger, you know what the voltages are. Also, you have to have a very good picture or video for all the resistors here, like this. So in the next chargers, if you find some burned resistor that you cannot read the value, you can use this video or a picture to know it. Also, you have to do the same with the ICs and semiconductors, because even they, when uh, get burned, broken, you may have it hard to read the type of the markings. Now let's after we check for all the resistors, their values, we have to measure the voltages in all electrolytic capacitors, like this, and keep recording that. You see, 316 once when you don't have the battery, and then when you have the battery. Now let's see that capacitor there. I think is this one. No, wait a minute. This capacitor here. Okay, we can test it from this side. You can measure the voltage. One here and here, and it is 14 volt. Let's do the same with all these others. These two here are in parallel, so we don't need to measure in both of them, but just in one of them. This is the output voltage. Okay, now these two here, 0, 5, 0, this may be for the LEDs in here, And this one here, this one here, no voltage. Another thing is to measure the voltages in the optocouplers here, here, and on the other sides. You also can measure the voltage in ICs just by putting the negative probe in the ground, where is the negative part of the capacitor here, and then measuring the voltages in every pin of the IC. So for every IC you want, you take notes, you record everything. Now let's put the battery and see the difference. Charging. The things change when the battery is on. Let's see this capacitor here. No voltage there. The capacitor of the LEDs, this might be blinking one, you see, blinking voltage here. The other one is also blinking. This diode here, 0.404. This diode is a normal diode, you see. And let's see the voltage on these two capacitors in parallel. You see now is 19, almost 20 volts, and it will keep rising, I think. You see, it is charging. And this small capacitor here is, this capacitor is the voltage of the IC here, and now it is 25 volts. It was 12 volt when the battery is not put, but now it's 25 volts. Also important is to measure the voltage of optocouplers. You see, there might be some differences. So if next time something is different when the battery is on or the battery is not on, put on the charger, uh, where the difference of the voltage is, you have to check around why the voltage is not the same as in when the charger is okay. So you can spot, you can measure semiconductors in diode mode. You can measure resistors, they have the value, or just visually check them or measure. So that's it. You also can measure the frequency in input or output of the transformer, like in this case here. Wait, it's not plugged. You see the frequency. It's 1200 hertz, but when you put the battery, '88 kilohertz, and the duty cycle 76%, 13%. Okay. Okay.